So a few weeks ago, I picked up a few swords from a local auction for about 70 bucks altogether and decided to turn them into projects. I wanted to start out with this machete sword that I believe was used in Cuba or Mexico in the late 1800s. If you know any background on this exact sword, please let me know in the comments. I'll post what I know in the description. Before cleaning the sword, I felt this was a great opportunity to sample a few chemicals I have been experimenting with lately. I started out by leaving a few drops of each chemical for 5 minutes, but this was too short of a time period. However, the bubbles from the 50% hydrogen peroxide were cool. Next, I left a few drops to sit for an hour, then wiped off each test section with a paper towel to clean off any remaining solution. I was finally getting some reactions. The 10% citric acid solution formed a solid black iron oxide layer. The 50% citric acid solution also formed a black iron oxide layer, but it wasn't as complete as the weaker concentration. The 50% hydrogen peroxide removed a small amount of rust and cleaned to the exposed steel. This could be interesting to try for a longer period, but the hydrogen peroxide would need to be replaced periodically since it slowly decomposes into water. Now, while the 32% copper sulfate solution isn't intended to break up rust, it does plate all of the exposed steel with a thin layer of copper. Since all the water evaporated, we can see the blue copper sulfate crystals and even a bit of yellow iron sulfate. I wanted to include copper sulfate because this is how I will be plating the copper onto the sword in my next video. The 6% potassium permanganate solution had no effect and predictably stained the metal. I wanted to include a solvent, so 91% isopropyl alcohol was a quick, safe pick that instantly evaporated and did absolutely nothing. Last but not least, 5% acetic acid, better known as vinegar, reacted primarily with the exposed steel and formed a black iron oxide layer. A reasonable next step is to wet sand with a few drops of each chemical and 400 grit sandpaper. While not perfectly identical, I attempted to apply a similar amount of pressure and duration to each section. Going from left to right, we have the control that I will wet sand with water later, then both 10% and 50% citric acid. With purchasing 1 pound bags, a 10% citric acid solution is roughly the same cost as vinegar, so citric acid could be a cheaper alternative if bought in bulk or used at, say, at 5% concentration. I also like the fact that it's a stable granule that is easy to dissolve in water. Next is the 50% hydrogen peroxide and 32% copper sulfate solution. The result of hydrogen peroxide was favorable, but it is fairly expensive and not as stable. Wet sanding with the copper sulfate exposed more steel and in turn plated more surface area. And finally, the 6% potassium permanganate solution, 91% isopropyl alcohol, and the 5% acetic acid solution. The potassium permanganate solution and isopropyl alcohol are both capable of cleaning but are far from ideal. The potassium permanganate continues to stain surfaces, and the isopropyl alcohol, just like most solvents, quickly evaporates into noxious fumes, making wet sanding tedious. The acetic acid solution does a great job and reinforces its popularity for this purpose. Water alone can slowly remove rust when combined with abrasion, but it is not as efficient compared to one of the weak acid solutions. To review everything in detail, here are some close-ups of each section. While the sandpaper does most of the work, the chemical for wet sanding is a contributing factor, and my two personal favorites are going to be the weak citric and acetic acid solutions. For the most part, this sword is in very good shape, which made the cleaning and copper plating in my next video relatively painless. Thanks for watching, guys and gals. Arisolder, out.